Hello everyone. Today we're looking at the periodic table and how the elements are ordered according to their electronic configuration. Here we have a periodic table and the elements with the same valence electrons are in the same column. So, for example, hydrogen has one valence electron, that's one electron in its outer shell. Lithium has one electron in the outer shell. Sodium has one electron in the outer shell. All the elements in group 1, that's this first column, have one electron in the outer shell. So the chemical characteristics are kind of the same. The second group also has similarities. They all have 2 electrons in the outer shell. Over here in group 13, all these elements have 3 electrons in the outer shell. These have got 4 electrons in the outer shell. Group 15 has 5, Group 16 has 6, Group 17 has 7, and Group 18 has got 8 electrons in the outer shell, except for helium, which has only got 2. But because that shell in helium is full, then it has similar characteristics to these other elements, because their outer shell is also has 8, which is a stable configuration. So you can see that the elements are ordered in a way which corresponds to their electronic configuration, and that also corresponds to how what their chemical characteristics are. So all these elements here in group 18, they're all inert gases. They're all kind of the same. These elements over here, apart from hydrogen, these elements here, they're all reactive metals. These ones in group 2, they're all fairly reactive metals. So you can see there's some similarities there. That's why we do it like that. Now, in group 1 and group 2, the outside electron, the valence electron, is in this S subshell, so we call this block the S block. Over here, from group 13 to group 18, the outside electron, the valence electron, is in the P subshell, so we call this the P block, except for helium, which isn't. But all these other elements are in the P block. And this block over here in pink, all these elements have got a valence electron in the D subshell. So that's called the D block. And these ones down here, they've got their valence electron in the F subshell, so that's called the F block. Okay, so the periodic table is, once again, you can see it's set up according to the electronic configuration. So if you don't understand electronic configuration, go back to the previous video and have a look. Now these elements here, around about these ones here, these are non-metals. So we need to remember that the non-metals are over this side and all the other ones are metals, and that's the characteristic there, that they're separated in that way. Now, another thing to remember is that an element like lithium has got 1 electron in its outer shell, and if it was to lose that, it'd have the same electronic configuration as helium. See, that's 1 less. So 1 less than lithium is over here at helium number 2, and helium is an inert gas. So, in fact, lithium does tend to lose 1 electron and become exactly like, well, similar to helium in being very stable in this electronic configuration. So lithium tends to lose 1. Sodium also tends to lose 1. Calcium, all these ones tend to lose 1 electron and become like the inert gas, which is 1 element lower down in the periodic table, the one before it, just on the other side. Now these elements here, fluorine, if it was to gain 1 electron, it would have the same electronic configuration as neon. So all these ones here, all the group 17, they all tend to gain 1 electron and become similar to the inert gases as well. So the characteristics of a lot of the elements on this periodic table are sort of determined by things wanting to become like group 18. Fluorine tends to get 1 electron, become like group 18. Oxygen tends to gain 2 electrons to become like group 18. Nitrogen can gain 3 electrons and become like group 18 as well, like neon. That's about it for now. Bye.